Do you hear me?
Yes.
So 3 minutes from me. I introduce Valentina, my best friend. She is International Committee of IOI, you know, and she is editor of some international journal in informatics. And I'm happy to know you, and you come here to see my students. Not just only my Olympiad, okay?
Hello everybody, I'm really very happy to see so many young people in one place, and it's really, I'm doing my first lecture with so many students. I did in Taiwan 2 years ago, but it was less students, so you have very... And what I wanted that my lecture will be not very seriously, it will be more like you need to interact and you should ask questions. We should work together because you know much better many things as me. That is, you have, we have here intellectual brain together. Not only one person, but now you are here 100. Yeah? And we can talk together and learn from each other. But at first I wanted to ask you, do you know where is Lithuania? I am from Lithuania, in my language is Lietuva. Some people in German calls Litauen. I don't know how it is in Indonesian language. Lithuania. Oh, it's very good. Do you, who knows where it is and can tell? No, not you. I'm not allowed. Just only young people. Who knows, who can tell where is Lithuania? Please, me. Oh, okay. Please tell.
Lithuania is in the Eastern Europe near Latvia.
Oh, you know Latvia, our neighbor country. Great. So I have small gift to you. Come. It's magnet and the Lithuania map. You can see that above is Latvia. So, very good. Oh, you learned? Oh, you learned your... But you can use devices. Do you have mobile phones? You can do this in 1 minute to search. Why you not do it? You should be very brave. Just... I am not so good.
Not allowed.
Not allowed? But you can just... You should use your external brain. Why you're not using? Okay, now we will start with... So you see, my my talk will be on computational thinking, constructionism, creativity. Computational thinking is now very important in the world, and if you can add something or ask me anytime, you can ask me, and we can discuss. And constructionism and creativity also, it's very important. If you want to live in a better world, to get a better job, to be influence companies, to establish companies and so on. It's very important. It's long-lasting goal. Now here is some about facts about Lithuania. You see that we are in the middle of Europe, and Latvia is above us, and this is Lithuanian flag. And here you see that person was right. Here is in the, like, sometimes we claim that Lithuania is in the middle of Europe, but there's several countries in the middle of Europe. So this is statistical data. You see that we are a small country. Its population is about 3 million. How many inhabitants is in Bandung? So Bandung is bigger. But why you ask? What they are doing? Do you know how many people are in Jakarta? 12 millions, yeah? Okay, so it's 3 times more than in Lithuania. No, 4 times more. Yeah, 4 times more. So, and our currency is... Can you read? I'm asking, our currency, Lithuanian currency? Euro. Yeah, you should follow slides. And what is our, we have borders, our neighbor countries? Belarus. You know maybe Belarus, if people are from IOI, that Belarus is very strong and they usually have, they had the youngest gold medalist from like 12, 13 years old. Yeah, you know very well. And what is with Russia? Do we have long? What about Russia? Do you know that we do not? We have very small piece of Russia. This is not connected with big Russia because Russia is somewhere here. But we have this Kaliningrad, very small piece that is not connected with Russia. So this is also geographical some information. But when you touch, you always should be interested to get. And this is a little complicated because it's here Poland. Here, this small piece of Russia. Here is Lithuania, and these people from Russia, they should, to go to Russia, they should across Lithuania. There is some special trains that they do not allow to go out because we need a visa to go to Russia, and they should cross Lithuania, then Belarus, and to go to Russia. This is some tricky. So what else? Do you want to ask me something? Because that's all. So now we will start what I wanted. I wanted to talk to you. Maybe I skip some slides, not everything. We will see how I will watch your interest, what you would like to know better. So as you see, this is a little about computational thinking. I provide. Do you know what is computational thinking? Who knows? Are you shy or you do not understand my English maybe? Because yeah, you know that Europeans, every country has own English pronunciation, and I'm sorry, I'm not British, I do not, and it's, but you can ask, repeat if I couldn't pronounce very well, so you can ask me to repeat, okay? So, and then I will introduce very little Bebras, but what I wanted much more to focus on what we are working, which concepts of informatics can be introduced through Bebras tasks, that you will do this, not me. You will discover, and we will solve some Bebras BV tasks, and you will see what you can learn or you can think how you can do in future. So, and maybe I will skip this about the constructionist learning, that I came from a constructionist conference from Bangkok, from Thailand, was international big conference. So now this is informatics or computer science, what it is, because you are informaticians, yeah? But in some countries it's interpretation different, and I was not sure that you understand, that we understand, because always when we are using some terminology, we should define, agree, that you understand it this way and I understand it similar way. Because we think that informatics or computer science is concerning with design and creating informatics products and tools, such as what is products and tools, algorithms, programs, applications, software, systems, methods, theorems, so it's under informatics. Do you think it's okay? Or you wanted to add? No. Okay, and ICT is more application, yes, it's focused on application. Informatics or computer science focus more on designing, producing, and the ICT is more focused on using and working. And both these directions can be creative for sure. In both directions you have creativity. So this is, I put some about some Europe countries, that informatics is very important in secondary school or high school or just primary school. Maybe you know that UK 2 years ago, now it's 3 years ago, and in 2012, because before they had focus only on ICT, but now they focus on computer science or informatics, but they call computing. So in UK is the same, informatics is computing. They made this new terminology, and here's, so if we, this is, I'm sorry, I don't know maybe very well Asia specific, but this is mainly from Europe countries and from states, United States. It's like schematical view for history. It started with teaching about computer and algorithms in the 70s, then go to creating programs, programming. Then in 90s we focus more on applications. It's ICT in all Europe countries, especially in Europe countries. And in 21st century we started like technology and learning in all subjects, because computers, all devices better. And now, like 2012 or 2013, many countries starting to think about deeper understanding of informatics. It means that we should make better software, that our software should be implemented in all kinds of life. And to make better software, we need better informaticians. Yeah? We need you to be very creative, not just to learn tools, not just to code or some, but always think how I can produce something new that doesn't exist now. So, in this way, creativity is very important. Okay, I will skip some. This is computational thinking. Do you know Seymour Papert? No. Who knows? Who have heard about Seymour Papert? At least one more. Who knows something about Seymour Papert? Do you know Logo, programming language? Logo. No. Which languages do you know? Programming languages. Java, yeah? Java. Because that's okay. And what else? C or C? C++, okay. What else? And now Logo, because yes, you are too adult, you are not taking care of this primary school. Yes, Logo is designed by Seymour Papert in very beginning. It was like 50 years ago, I guess. It's 1966, and MIT. Do you know MIT? Yeah. Oh. And Papert worked in MIT in 60s, 70s. And actually he created this Logo, the first language for with artificial intelligence. He was MIT lab that they started with to play with Logo, and started with Marvin Minsky. Do you know Marvin Minsky? Creator of artificial intelligence. Do you have lectures on artificial intelligence? Yes. And you don't know Minsky. Yeah, you are too young. Yes, you should. So they created this logo with turtle that kids can move, and logo is in, maybe you don't know, it's like you are using some tools but you don't know history, yeah? You are using, I'm for sure that you are using, when you're creating apps, you are using Apps Inventor or some other stuff. How you create apps? How you create? Do you creating some apps on your mobile phone or not? Or just using? When you're creating, what software do you use? What do you use to create apps? What?
Android Studio.
Ah, yeah, you can use the different, yeah. But I don't know this software, but maybe in some software, for example, I know, well, Apps Inventor, they use this logo-based some commands. You can, and also know it's Scratch. Do you know Scratch? Yeah. The Scratch is done from Logo. Logo was at the beginning, and then doctoral student of Seymour Papert, Resnick, created Scratch. How you can characterize Scratch? Just with one sentence, how you can say, what is Scratch? If somebody asks you in the street, what is Scratch? How you can tell? What? Yeah? Yeah, please. Yeah, it doesn't matter, just tell.
Many Scratch is a programming tools. I mean, it is a software, it is web-based, or maybe it is a desktop application that we can utilize to help us learn more about programming. Like we can use the for loop or the instructions inside. Simulate in the initial we don't really have the program, but we can like match the puzzle.
Yes, it's syntax free. Yeah, because it's you couldn't make mistakes, because this is it's very important for beginners. Yeah, for beginners, and it's a great idea. Based is like puzzles to put together. Yeah, this is great. And do you know Snap? What is Snap? Good question. What is Snap? You can Google. So Snap is, I am short with one sentence. Snap in Scratch, you couldn't develop these puzzles, these pieces, components. And Snap is for more advanced, that you can develop such pieces. It means you can write your own procedures. There are some others also from Berkeley University, BOB. It's build your own blocks. But you are very, very, very good, so I have Lithuanian chocolate for you. So, I can, thank you. Okay, so now we learned a little about the Seymour Papert. Seymour Papert is really a great scientist, and originally he made several nice ideas. It's like this programming languages for syntax-free, like Logo, artificial intelligence, new computer, actually Papert mentioned first time constructionism, because constructivism was already by Piaget or others. It's constructivism more about your mind inside, and constructionism is more visible, that with computer you can construct new things and learn how to construct and be creative. So it came constructionism from Papert and other things. And so computational thinking, this came from Jeannette M, as you see. Also she was working for the States, now she is working for Microsoft. And the first introduction of computational thinking was done in 2006, as you see. It's 10 years ago. And I was very happy to meet Jeannette M in last year in Korea, in Dagiene. I was big computer congress, and we meet together and then talk about computational thinking and BIVE contest, Bebras contest, and because we are also going to this direction to focus on computational thinking. I think that you have computational thinking, but computational thinking we need to all students. It's not for biologists, for philologists, and so on. So that's why it's this problem that in society, modern society, everybody needs some background in computational thinking. So this is quotation from Jeannette M as founder of this terminology. Later she wrote several papers, and later she made more precisely what is computational thinking. In the beginning you can remember very well that it's from 3A. First is abstraction, second is analysis, and the third one is automation. Base programming of only. And which part? Abstraction, analysis, automation. Do you see? What do you think about automation? What it is? Abstraction, what this means? Just think. If you have problem, for example, somebody asks you to build bridge. Yeah? What you are do? What you are going to do? Yeah, gathering information is very right. But you have a lot of information, yeah? You gather, and then you need to abstract to solve problems. Maybe you remove some data because it's not necessary. You started to then analyze it actually in parallel. You analyze your data and how it's better, what it should be, what your material have, and so on. And when you have this analysis in data, you can automate some parts. Automate it means that maybe you can, how to solve the problem. Maybe some parts you need to program, yeah? To get, for example, to make model, how you can get better with your resources. How does it cost? With one material, with another material, with how should be done, yeah? So this is computational thinking. You start from a real problem and to make solution. It's very good when you have automated. Automated, it can include, mostly included machine, computer, programming. If you can automate a task, it means what? That you can put robot. Yeah? And it means that we reduce human resources, then it's very good. But not all tasks you can make automation, yeah? Then you should, which part you can do with people and which part you can allow to do robot or machine. Yeah? This is main idea, and this is very main idea of computational thinking. To start with real problem, to make analysis, abstraction, and decide what can be automated. And then you can talk with programmer, with informatician, give them a task, and they can do. It's you can do, yeah. But you can do all this process as well. So, that I wanted, but maybe later, this how is competition and contest related to maybe I come later. I wanted to say that I established in 2004. I established Bebras contest. Bebras means beaver in Lithuanian language, but many countries are using Bebras as original. We learned that you do not have in Indonesia, sorry, you do not have this animal. Maybe you don't like how it looks like, but I didn't put here image. But in there, how is beaver in Indonesian language?
Berang-berang.
The most important, they have very strong teeth, that they can cut trees very well. In a few hours they can cut trees and make dams and water around the water lakes. And we call it like beaver, and as you see, we change that now. This Bebras contest is on informatics and computational thinking. When I started, it was more on informatics and algorithms and computer fluency. And now last year, we are international contestants. We focus for all age of students, and we focus now on computational thinking. That's why it is important. But I wanted more that you can see it, not just talking and talking. So this, you see, I told already that here is international challenge. Now we are talking not about only contest, but it's challenge on informatics and computational thinking. And so from, what is algorithmic thinking? What do you think? What is algorithmic thinking? Who can tell me. What do you think? What is algorithmical thinking? Do you write some algorithms or not? Yes. So, how you can tell that you have this algorithmical thinking, or how you can explain what it is? What it is? Are you very shy?
Yes.
What is algorithm then? What is algorithm? Who can describe? This is very main concept for you. This is a background that you are studying. What is algorithm? Okay, well, it's already.
Set of procedures.
What I didn't catch it, repeat.
So it's some kind of how you run function and procedures.
Procedures, yeah?
Procedures, yeah.
Okay. Yeah.
So first steps, next step.
Ah, first steps, yes.
Yeah.
That it means that you should have some order of steps.
Yes.
Yeah. That's okay. It can be more explanation, because for algorithms, if you Google, you can find at least 400 different definitions. They are all closing, because you know, when I ask you to describe what is stable, you will have different, but we have intuition what is stable, yeah? It doesn't matter if it's 3 legs or 4 legs or 5 legs, it is round, it is triangle, and so on. But we understand. That is the same algorithm. You understand, you have intuition, yes? What is algorithm? But when you need to make in words, sometimes it's difficult, but you need, because we should talk to other people. You will talk with your clients, and you should understand what they would like from you. Yeah, this is very important. And now we can, now we have this algorithms. Now we can start. What is algorithmical thinking? What do you think? Think. You don't need some. You should think. What you think? Yeah, okay.
Algorithmical thinking is about decomposing problems into sequential of tasks.
Yeah, very well. It's one of the very good. Very good. That's what more? What is algorithmical thinking? Okay.
Algorithmical thinking is a way of to get a solution to the clear definition of tasks.
Aha. To get you should have solution. Okay. What more? All you are right. Yes, this is different features as you know algorithms. What else? Yeah, solution is very important, because you can get this algorithm that's running, going, and there's no solution. It is not useful for us. Yeah. Also you should think, what about algorithms? What else features you have? Oh, okay. That's the main features you mentioned. So now we shifted, but algorithmical thinking is more strict. Yeah, that you have very strict steps, and you know how to go from one step to another step, what to do, like you mentioned these procedures, and you get your result. But not always you have this clear algorithm to make your morning coffee. You have algorithm, yeah? You should take cup and so on, and no detail, but you remember everything, what you put sugar, not put sugar, and you get coffee and drink coffee. Yes, this is algorithm, yeah? You can make machine, that is actually automate machine, that you put some stuff and you get your result coffee. So this is algorithm, but not in many cases you can get algorithm, but for example, like in 100 years. Yeah, and it's for human it's not good. When you, for example, when you need to solve some task, and if computer tells that you get your result in 100 years, then you need somehow to optimize, somehow to do. It means that it's some other, not only algorithms, or develop fast algorithms. You know that algorithms are complicated, but theoretically you can do in discrete mathematics or theoretically you can do. Doesn't matter its time. But for usability, that's why very important feature of algorithms, that it should be done in times that I need it, human needs, not in 100 years or in 1,000 years. Because it should be done in reasonable time. And this is and then you couldn't, maybe should start to talk about other things. And now that's why we put this shift from algorithmical thinking more to computational thinking, what is more broader. That is nowadays is more important. It's like cryptography and some others, optimization and some others sciences that connected to informatics as well that we can use, because these poor, if we know strict algorithm and can solve, then we can usually put robot or some automated machine and it's done. But in many cases, when we need to solve real problems, we do not have pure algorithms. We need to be creative and to do computational thinking. And here we for informatics for informatics, as you're doing to shift to informatics for all, that all students, all pupils, just the children, should have some knowledge like in mathematics. In mathematics, every children gets some knowledge, yeah, because it's needed for life. And now it's the decision that it's informatics needed to everybody, because we are in modern society and we need some little knowledge, little understanding or intuition, what is this computational thinking, what is informatics. That's why we established this Bebras to solve nice, interesting tasks and to get some intuition, or we call like concepts behind. Okay, now here is already showed before, and this is some websites from other countries, because there are many countries doing, as you see, Finland, they call Vive Majava, and this is online contest, and here's, which page here do you see? Which country? Okay, Japanese, well, yeah, you can be fast to check. So this is, you see, this level of Vive, Japanese Vive with big teeth, yeah? This is Lithuanian. You see a Lithuanian web page in my language, and this is actually a logo of Lithuanian Vive, also with two big teeth, and this is Bebras. Okay, now it's time to you see this. We have this five age groups. Actually, this Vive contest is not for you. It's for pupils, but how you can contribute to Vive? You can make nice tasks, yes? And it's very, very challenging. It's like to contribute to make interesting, like games, short games. You can make interactive games short for any age of pupils, and you will be satisfied that many people are using your task. So this is main goal, that you can think and contribute to a community. So here's you see that started from age 8, 9. Some countries already started with just 7 and 6. So you see, we are now 36 countries. 36 countries did last year, but we are now growing. More countries are coming, and as you see, so maybe 2016 in autumn, so I hope that Indonesia will join. So this, what Vietnam already are members, South Korea already. And here's some numbers, some participants, but and many girls. So we are very happy that in Vive contest we have the average is 40% of girls. But in some countries, you see, Taiwan has more than half contest girls. So, Malaysia also, but Malaysia has not so many, but Taiwan have more than 20,000 participants, and it means that more than 10,000 are girls. So it's very good to involve female students. And know what is main important in Bebras contest, in Vive contest is more important is to solve short tasks and to think, to be creative. Means that you should think very, give your deep mind that you don't need knowledge actually. When we create, that's very hard to create, but very hard to create tasks. And we have community of teachers, students, each country has its own, but we produce internationally, and we estimated that to make one task, this for 3 minutes usually, this task should be solved within 3 minutes. It's average for contest. And to make this task in informatics, you need about 1 month. If you work if you can spend 4 hours per day, so it means you need 1 month to make task, good task. So it's really challenging. It's really every day you can rethink, to formulate, to make picture, to make better, and then this task will be good. It's not like just some people as you know, so very talented, gifted. Okay, maybe can make in several hours, but it's usually it's not. So now we developing solving tasks, and you see that should be all tasks should be computer science related tasks and involve computer science concept, and they need computer science concepts. You see that is algorithms, that is procedure, or this is some mapping, or many that you learn. Many concepts we should bring to your younger generation, should bring that they can solve without knowing this big theory behind that you know. So this is I already mentioned, but I wanted also to one more time, that is so that participants could have as equal position as possible. So that it means that the task should be free of some specific software, or just we are not using Scratch or some other. We just everything is and should be short. So as you will see that everything should be in common language that everybody can understand, but concepts are hidden in the task. Now we go to. I would like now to. You remember computational thinking that Jeannette M described, and I told you about 3A. Do you remember? Who remembers still? Oh, okay. What is this? What is 3 words? Can you tell me? Abstraction, very well. Analyze, very well. Automation. What is automation? Somebody can explain me. What do you think? What is automation? So, can you explain? Explain to your colleagues what is. Okay, 3 minute break. Explain in pairs to each other in your Indonesian language. And Inga will summarize to me what you are talking, okay? 3 minutes to your neighbor, explain what you mean by automation. Okay, that's one person. No, they should talk now. Yes, or you can summarize what they do. Okay, so now you got from your peers, yeah? Who can, I saw, but now maybe somebody else, who can, what about you? What about you talk? What did you talk? What? Okay, so, we have
for us, automated is simplification of the solution to become to use by system. So we are not so many used by human thinking, but the system doing it well.
Very well, very good simplification. It's very you use very good concept. What else you can add more? What you talked? What you did talk?
Me.
Yeah. Okay.
I phone my friend. Actually, I know someone who can answer. Because I've already answered so many times.
Yeah, it's kind of automated. Yeah. Okay.
I want to call my friend Feriandi.
So your friend is not answering.
No, he should be able to answer it.
How do you encourage him? Do you have some gift for him?
Yeah. No, he's my friend. I think he can answer it, but yeah.
But you should interview him and then rephrase what he's telling.
Okay. Basically, it's no human intervention.
No human intervention. Oh, it's very interesting.
So yeah.
So it's a poor term. It's totally automatic. So it's a very strong automated system. Yeah. Okay. And you wanted. Can you add something more?
Actually, all have been answered about the human intervention. Actually, the keyword there is the human. We decrease the interaction between human manually controlling the system, while in the automation, the system will work more by itself automatically.
Yeah, that's very good explanation. What do you think about specification? One thing is very important. Do you have this like specification of this terminology, like specification?
Specifikasi.
Yeah, it's international. What do you think? Is it important in automate when you're developing automated systems? What is very important also, so imagine you need to make some automated system. What is very important for you? What? Algorithm. Okay, algorithm, you need to know how it steps when you develop it. What else? Because it's close to specification. I don't know if you use it, that you need what to do, yeah? And you should agree. It's close to algorithms. It's very important because when you develop automated, you need to agree on which steps. For example, you're producing some kind of software for like financing. You need to know what is requirements, what are requirements maybe. It's like specification, technical, because what systems you have, yeah? And the software requirement, for example, you need on this big machine, so you call more, or you need to, which data will be. It's different if you have thousands of data, or if you have billions of data. Yeah, it's very different. Yeah, so for automation, it's very important. Okay, now we have continue our computational thinking, it can be, you see, this is quite interesting definitions that I like. I developed several others, like modified definition, but this definition called operational definition, and it's made of two organizations, international organization. One is this on international teacher education, and another one is American Computer Science Teacher Association. They quite famous, and they actually they suggested this operational definition. Operational means that you can easy to when you have some problems, you can easily make by this steps of, like, it's like algorithm. What is a computational thinking? And if you read some papers and if you go to more deep computational thinking, understanding, or especially if you want to apply to some real problems or to some courses, then this operational definition is very helpful. So that is like definition breaking in some components or pieces. So the first one is, you see, this is formulating problems in a way that enables us to use a computer and other tools to help to solve them. Actually, somebody of you mentioned this is connected with automation, yeah? Because this is three: abstraction, analysis, automation is not very concrete. That's why we mentioned this, like to understand what is computational thinking, but this is one is more concrete. There are also with 9 components, bigger. There is UK developed with 12 components, but it's sometimes is similar, just making in small pieces, but I like this with 6 components. This first is formulation. The formulation from some real problem you should reduce to simplify. The second one is logically organizing and analyzing data. For you, it's very clear, yes? You are working with this, that to organize data that you have, yeah? Because all programs work with data. And the third one is representing data. Is it important? What does it mean, representing data? What does it mean? Who can explain? Did you have some course on data?
Yeah.
Yes, that's fine. And what you did, what you learned, what did you learn? Something you don't remember, yeah? What about data? Can you make me some few concepts what this? Have you heard something? Oh, yeah, structural data. What does it mean? Do you know structural data? Can you give me one example of data organizing? Can you give? You can in Indonesian language, but I have interpreter. Yeah. What kind of data you know? What you work with which data you work in when you are using Java or C++? What data types or data structures do you have? Array, yeah? Okay, fine, very fine. Matrices, yeah, many, yeah? What else? It's too simple for you, yeah? Just why you don't want to talk, because you said it's childish, yeah? But still data you need, it's your life. You couldn't do anything without data. But what does it mean, representing data? What does it mean, okay?
The main representing data means that a method of converting a real-world data or information into the type or structure that the computer understands.
Very well. It's from life to machine, yeah? But it's also other way, yeah? when you get some results, you need to see if you get some, like, for example, like 10,000 numbers. It's not visualized, then you couldn't. And if you get some nice graph or something nice, then you can, for human, you can read much faster. You know this, now it's a terminology, infographics, yeah? Infographics, that we can just look and tell that, oh, there is some problem in this space, and this is, and then you can go deeper. Thank you. Okay, now we go. We talked about automating solutions through algorithm thinking, a series of ordered steps. So you already did. We all did. Yeah, we learned already. And identifying, analyzing, and implementing possible solutions with a goal. So this is to reach solution, to get goal. And the last one is the sixth component is generalizing and transferring this problem-solving process to a wide variety of problems. This is quite difficult, but what it doesn't mean, maybe I will start you, just that it means that when you solve one problem, you should think how you can use this process, your thinking, your solving, to another problem, to different problem. This is very important because it's then you can, when you process is in learning, process is much important than result or outcome. That it's like in vivid challenges, more important way of thinking than to get right result. And now, especially in many Europe countries, we are just in mathematics or in informatics, we are paying a lot of attention on way of process, on way with thinking. That's why we are interacting with you, because it's very important how you think, because then you can repeat. When you get very fast this result or so, you maybe couldn't understand way of thinking this process, and this result is not so important. Of course, then when you do real things, you need to get good results. But especially when you're studying, when you're learning, the process of thinking is the most important. So now we have this six components, and now we do you need few minutes to relax? Then we started to solve problems, and it's your side. Now you should think, very think, and discuss and do some bigger tasks that they are developed for young, your brothers or sisters, I don't know, or nephews, what do you have, but you should take a look and you should solve them. And I put one task by each computational thinking, because we have thousands of tasks, but I put like just to start with you. Are you ready to start? Yes. Okay. So first one is here. Actually, you should solve in 3 minutes, but it's up to you, because it's you can read and you can talk with your neighbors if you need. And when you get solution, the very important is to explain why you think the solution is this or this or this. Okay? Now you have 2 minutes, 3 minutes. If somebody already wanted to explain, just raise your hand. Oh, okay, true. Okay. Are you ready to listen? Yes. Yes, okay. You first.
I think that answer is top one.
Can you louder, because I'm not sure that they...
After discussing with my friends, I think that the answer is the top left.
Why? Just to explain why.
Okay. The reason is, I think the right answer is about the top left and the bottom right. But if we see that there's a two beaver, and one is smaller and one is the big one. The distance between flowers in the top left one is more farther, and it's representing that that's the big beaver do. So I think the correct answer is the top left one.
Do you agree?
Yes.
Why do you think this one is wrong? Left first, yes, very. So you can. So this means we should use only these three ones, because easy. First, this one is wrong. Yeah. Why is this one is wrong? Smaller one. Yes, very easy. So it's for you. It's very easy. Yeah. And why this one is? Yes, steps is smaller. Yeah. For this bigger. Yeah. Well done. Very well. You did maybe in 2 minutes. Excellent, students. And now, yeah, cadets is like 14 years old. So you are good. So, but now it's the most important part. Why do you think that it's not like fast? Why do you think that it's good for computational thinking? Which informatics concepts you find here? Can you find? What do you think? Which informatics concepts you can? Do you remember I showed this with computational thinking, that is formulation very important, yeah? You remember one slide? You remember? This is a task example from computational thinking, that is formulation in a way. Yeah? Actually, this problem is formulated that you can program. Yeah? This is with computational thinking. So now we can find several concepts, informatics concepts. Which one you can mention? What you see here? What? Just very. What is this written? Repeat, repetition. Yeah. For you, it's nothing special. Yeah, repetition. But you remember when you were like 14 years old, 12 years old. Repetition was not so useful. You're not so like everyday life. Yeah. What else we can find? What is this? Sequence. It's algorithm, yes, it's algorithm, how to do steps. Also it's like some abstraction, left, right, forward, yeah? Okay, let's move to another task, we will see. So now it's about what you are, well, I think that you are very well doing, everybody of you. So you have then 2 minutes to discuss, to argue with your neighbors. And raise your hand when you are fast. You are fast again, okay? That I keep. Are you ready? 1 minute? Okay. Are you ready? Almost ready, yeah. What's your name? Kevin. Okay, so now Kevin explain. This task is for 10 years old. Okay, please explain which.
The correct answer is 8. Yeah, because it's correct. I mean, there's an umbrella and
yeah.
Umbrella don't use anything in her head, and there is a sea in the background.
Yeah. It's very easy, yes, it's easy task, but you can imagine, and maybe it's like more puzzles, yeah? Sometimes we are discussing, we teachers, we're discussing arguing very strong. Is this mathematician only mathematical thinking, or but informaticians needs logical thinking? And you know these operations, all logical operations is comes from mathematics, but we need, and for kids we need to have such kind of tasks. Yeah? Do you agree that we need such kind of tasks? And especially for the smaller kids, and this for 8, 9 years old, it should be very little text because they are reading. Usually alone one sentence. Everything should be done in. I haven't showed you interactive tasks because I should connect to system and maybe to later, because I do not have here interactive tasks for small. We have interactive tasks. It means that you drag, you click, you can in this task, for example, for smaller kids you just ask to click or so to play with like games. But we have special systems that you can imagine. This is yes, I'm showing you because it's easy to show for. Because you are, but for kids it's better to have interactive tasks that they can. That's more fun for them, and this is okay. For your activity, I give, and now you refrain in chocolate, but you should now be more silent. You can raise your hand, but I will ask other students. So, now we have for representing data, what was quite hard for you to explain to me what you will learn. Yep. Now we see what tasks. Oh, by the way, this task, who made this task? Can you see? Japan in 2014, because we already recorded all tasks, and it's actually its idea, because we worked internationally and we rephrase, and we actually it's a huge process, but we still keep all records, who made picture, who improved, it's like we have thousands of tasks, and this is, okay. So now we are going for tasks that you have 3 minutes to solve, and raise your hand. No answer? You know already? You know, you are fast one. Okay? Are you ready? Yes. Okay, so you was fast one.
So I think the answer is map 3.
Explain why?
Because every node is the blue one have two neighbors, and it is in the graph. It is the top left node in the graph, the blue one. And then the green, it has four neighbors. It is represented by the top right node in the graph. Top right. The green one is at the top right in the graph, and the orange one is have four neighbors and represented in the graph by the left node in the graph. In the center blue is represented by in the graph by the center node. It has 5 neighbors. And then the orange right, it has 3 neighbors and represented by right node in the graph. And the left one, it has 3 neighbors and represented by the right bottom node in the graph.
Okay, how you solve? Because it can be different strategies. How you started to solve? You explained well. Your explanation is very well. But how you started to solve? Can you explain?
I look at the graph and the node has the one have 2 neighbors, and I search in the picture and I eliminate the map 1 because it has only 1 neighbor in the orange left top.
This you eliminated. Yeah, this is very clear. Yes, everybody maybe did this strategy. Yeah, you can eliminate this one. Yeah, that's all.
Okay, and I can eliminate the map 2 because the green bottom one is only have 2 neighbors. Green bottom.
Yeah, this one. Yes, 2.
Only
But why you eliminate? Because it's 2. It can be this one.
But the another blue one.
Okay. Yeah, you eliminated this one.
And then I search through every country, the map 3 and map 4, and I count the neighbors and compare it to the graph.
Okay. So does anybody has a different strategy? How you solve? Can you explain your way of thinking? Everybody thinks that's the same. What's your name? Bimo. Everybody thinks the same. So he's leader and you're thinking like he. All of you. For example, me, I would start to think like, okay, I can go around from these countries, yeah? In which graph I can go around? If I take this one, can I go around? No. Then I eliminate immediately this one. Of course, I can, it's for sure, I can eliminate this one as well, because it's only single, where you notice also everything. So it's different strategy. Do you have something different? Of course, you mentioned many of the strategies that you can count at 5, but he is in several at 5. This has 5 nodes that you can expect. But this is the most important part when you create a task, to create these 4 choices very clever, in very clever way, yeah? Not like stupid, but each should, why it is. Why put this one? Why put this one? Because this is, depending on the age of some, this is quite, that you can notice very easy, but sometimes we are. And now it's hardest part, why it is informatics? It's main question that we need to answer with each task. Why it is informatics? Why do you need this one to improve your computational thinking? Or you can argue that it's not informatics, what we are doing many times. That sometimes it's like people from different teachers from different countries have it very strongly. No, it is informatics, it should be. Now it is not informatics, it can be put in mathematics, or usually mathematics, or some else, but it's not good, not support very well or something. So please tell your opinion why it is informatics, why do you think? Are you tired? Are your mind tired? Oh, I got it. Okay. Can you allow that?
It's an abstraction.
It's abstraction, yes, it is abstraction. What abstraction?
From map to graph.
Yeah, from representation. Yeah, you can get it in different ways. And this is like countries, country map. You can this is also abstraction of country. It can be, we had another task that we made this on payment, like payments, this different shapes. Also, you can go to graph from real life tasks, and yes, like from math. This is abstraction. Yeah. What else? More suggestions? Or yeah.
Because it has some patterns, like because it has some patterns, like you can learn the patterns because sometimes in informatics you usually learn by the patterns, because it's helpful, for example, for
yes, very important. You mentioned this pattern and sometimes pattern recognition. Or you know big data. Yeah, you get about big data. What is more common? In big data, you need to search for some patterns, yeah? Because when you have patterns, you can tell. And big data comes from like medicine or so. And if you see some patterns, you can estimate this is some virus or something, some illness, some diagnosis or so. And it's many. Yeah. This pattern recognition is very important. And he actually wrote this pattern very well. Thank you. Okay. So now what we talked. From automating solution. Yeah, that is key. More text, it's because it's junior, it's 15 years old, 15, 16, Are you ready? Are you ready? Yeah. Are you ready? Yes. Okay. So William already raised hand first. He will explain why.
Because I just simulate the drawing things in my app, and actually I was lucky because I simulated from the bottom.
Yeah, but you should always think to remove the faster movement. The best strategy is to see what you can remove fast in the fastest way.
Actually, the first one is a function. You know, the second stuff is not needed there. So, like the row to be and third ID, you have to done with that, and there's also the row 1. So I just calculated that.
Yes, you can very easily eliminate. Everybody agree, yeah? That if you see draw one is in the middle. You do not have in the middle. It's fastest way is just eliminate. You have only 3. Yeah? Yeah. And what about B and C? What you can tell? B and C? What do you have, Al? Different? What did you?
Actually, it will produce the same pattern because if we switch the 2B and 2A at the front, it will produce just exactly the same. So if one is wrong, then the 2 is wrong.
Yeah, they produce, the B and C produce the same patterns, yeah. That is very good that you notice that is because they are already, these commands change, and doesn't matter in this case. If you think that you should notice, very good that you notice that B and C produce the same, that it's enough just to check one of them, yeah? This is good strategy.
And actually, the answer will be exactly 1, and if the 2 produce the same pattern, and it definitely will be a wrong answer.
Yeah. Okay. Everybody agree, or do you have some other strategies how to solve? You have, okay?
Answer B and C. I think a look at the last step, draw to A. Yes, the last step are draw to A. The B and C. It is draw to. No, B and C. The last step is draw to A.
Yes.
That's right. When I take a look at the draw to A, it will draw the pattern by what do you call it? Diagonal. But I take a look at the what you call it? The pattern. I think because it's not what would you call it? It's not diagonal. So it is best if I use draw to B because not diagonal.
The horizontal.
Yeah.
Yes.
So then I eliminate the B and C, and
Yeah.
then take a look at the but previously I will to count. There are 6 dots. So then if we only have for the answer for A, it is 2, 2, and 1, so it will produce only 5 dots. So
Oh!
that eliminates the A. So that eliminates A, B, and C, and then I got D. And then
Very good.
And then it is correct.
Very creative solution. That I first time I hear such good strategy. Now I should remember. And so, one. Baby, what's your name? Have you left? Okay, so thank you, very good strategy, and it's very creative, very deep thinking strategy. So it's maybe clear by this computational thinking because you see many commands. So now we have more analysis implementing is not easy step, and yes, more a little complicated, but maybe it's easy for you with the process closer to programming. Are you ready? Oh. Are you ready? Almost, yes, almost. Okay, so the first one I wanted to explain you.
So I answer here.
For steps 5.
The first step is to put the number between numbers 1 and 6, and then put the number 3 into between number 2 and 6, and put the 4 into the between the 3 and the 6 group, and then put the number 5.
Okay. Can we do less steps, like 3? How you can prove that the minimum is 4? Okay.
I can prove that the smallest step is 4 because we get the big number from behind. It is if we find the biggest number from behind is 9, 8, 7, 6, and 1. So that is the static books, and we must remove the others, and that is the smallest number we can get to rearrange to be sorted books.
Excellent. You are doing better and better. So it takes time to understand each other, yeah? So, excellent. This is actually what is written. You told us the date that the largest increasing subsequence remains untouched. Yep. Excellent. Do you want chocolate? Are you good to catch it? he has several concepts. One of them is like invariants. Do you know invariants? Yeah? Can you recognize here invariants? You mentioned, yeah? Some untouched box, yeah? It's very important when you are programming to recognize some invariant parts. And it says algorithms and so on, yeah? Okay, let's move, because we have the last one from the computational thinking examples. Oh, by the way, who can tell which country it is? EE. Very hard question, yeah? Especially when you do not have your external mind, external devices, yeah? Maybe it's not possible for you, but I still wanted to check if you... But this is knowledge. I love this knowledge. You can easily do, but maybe somebody, what do you think? There's 3 Baltic countries, but I'm from Lithuania, as you mentioned Latvia, and the last one is Estonia. So English, your teacher is very excellent. So this is Latvia. It's where we are Baltic Sea and 3 Baltic countries that we got independence in 1990s. Lithuania was the first one who broke the Soviet Union, and we got independence in 1990s, and this was, and after that Latvia and Estonia. And Lithuania is the biggest, 3 million. Latvia is 2 million, and Estonia is 1 million. But Estonia is very good doing in one, like e-electronic, e-government, is many, and I'm proud of our Baltic neighbors. They're doing much better than Lithuania. This is, and as you see, this is actually, it's a real picture from encyclopedia, from Estonian, that they have many volumes. This is connection with arranging for librarians. Okay, this is actually its task that it should be interactive, that here is not interactivity. You should, students can put this, as I told you, can drag and put in 2 boats and arrange, and it's that you can see what is interactive task, but just I'm showing just like example, and if you want it you can read, but I wanted to show few more tasks. Okay, I'm not going to talk here. No, I will show, of course, we have many tasks with Beaver, and I should show you some tasks with Beaver. So this is one task, because usually, especially for youngest kids, there are many stories with Beaver. That Beaver, Bebras, or what is your? Bran should do. So, and you can, maybe I can make a little. Okay. Now you see that this task is from Australia, from neighbor country. Are you ready? Are you ready to listen? Yes? Yes, okay, so please explain how you solve. How did it solve?
I think the answer is 15 minutes. How can we? There are three first. The first are the three round full, so it takes 10 minutes. Then the second, simultaneously with the first, only half takes about 5 minutes. Then the second move to the other three. Cut down all, it gives 10 minutes. Simultaneously with the first is, cut the half the rest. So it's 15 minutes.
Okay, well done. Do you have other strategies how it can work? How Bebras can work? Maybe somebody can do in 10 minutes? What do you think? How? How you can do it? Why it is informatics? I'm just making you questions that you can think. Why it is informatics? This is funny stories, that's all. Why it is informatics? Why it is computational thinking? Which concepts are behind? What do you think? What do you think? Are you tired? Yes. But still, it's maybe the last one that I wanted to know. Why it is informatics? It's very important. Actually, it's CPU, your processor working in this way. Yeah? Do you agree that your processor is working in this way? It's like multitasking. Scheduling. Yeah. This idea is that you should have, actually scheduling is very important also. And of course we discussed about this task, maybe it's dangerous and we can cut in half, we can fall down maybe. We might discuss, but it's Australia maybe they have strong, very strong trees that they maybe stay cut down to half of. Okay, so maybe, because you are tired maybe to solve that, maybe I will show one more task, maybe something different or interesting. Is actually I wanted to show you. And you don't need. Right. Okay, this is a similar task to. And this is I wanted to show because it's Lithuanian task. That's bakery and bagels. Of course, in Germany also it's very common to eat bagels. Excellent. This different strategies that I know.